Hello everyone, welcome to online Savi video tutorial on applied hydraulics. Today we are continuing with the module 4, that is hydraulic machines. In the previous class we have seen the introduction to the hydraulic machines and different types of heads and efficiencies. In this class we are going to discuss the classification of turbines, and we are going to discuss one of the type of turbine, that is a Pelton wheel turbine. So we have different types of turbines based on different parameters. So the first classification is based on the type of energy at the inlet. Okay, so based on the type of energy which is available at the inlet, so it is classified into impulse turbine and the reaction turbine. So impulse turbine means the energy which is available at the inlet, if it is only a kinetic energy, then that type of turbine is called impulse turbine, and the Pelton wheel is an example for the impulse turbine. So reaction turbine means, so if at the inlet of the turbine, so both kinetic energy and pressure energy are available, then that type of turbine is called the reaction turbine. Like the Francis and the Kaplan turbine is an example for reaction turbine. So the next type, the classification is based on the direction of flow through the runner. It is classified as tangential, radial, axial and mixed flow. So tangential flow means, so here the water enters into the turbine, so tangent to the direction of the runner. Okay, so here the tangential flow turbine means, so water enters along the tangent in a direction tangent to the runner, then that type of turbine is called tangential flow turbine. So if water enters in a radial direction, then it is called the radial flow turbine, and if the water enters parallel to the axis of rotation, then it is called axial flow turbine. Mixed flow turbine means, so if it enters in a radial direction and leaves in a direction parallel to the axis of rotation, then that type of turbine is called mixed flow turbine. And the next classification is based on the head. So if the head is available is greater than 250 meter, so that the inlet, if the head is available greater than 250 meter, then it is called high head. So if it is available 60 to 250 meter, then it is called medium head. So if the head is less than 60 meter at the inlet, it is called low head turbine. And similarly, based on the specific energy, it is classified into low specific, medium specific, high specific turbines. So if the specific speed varies from 8.5 to 30 rpm, it is called low specific speed turbine. If it varies from 50 to 340, it is called medium specific speed turbine. If it varies from 255 to 340 rpm, then it is called high specific speed turbine. So these are the classification of turbine based on different parameters. So next, let us see one of the type of turbine, impulse turbine, that is a Pelton wheel turbine. See here, a Pelton wheel is a tangential flow impulse turbine, which is nothing but the water enters in the tangential direction, that is nothing but tangent to the runner, and this turbine is named after A.L. Pelton, who was an American engineer. And here, so the water will strike the buckets along tangent of the runner. Okay, and also the energy available is the kinetic energy at the inlet, and the pressure which is available both at inlet and outlet is the atmospheric pressure. So basically this type of turbine is used for a high head, and also head is available between 50 meter to 1300 meter, and the specific speed is about 8.5 to 30 rpm for us if it is a single jet, and it is varies between 30 to 51 if there are 2 or more jet. And let us see what are the components of this Pelton wheel turbine. So this is a typical layout of the hydroelectric power plant, which we have already discussed. So like where the turbine will be located. See here, the components of the Pelton wheel are, one is nozzle or a flow regulating arrangement, which is called a spear arrangement, and you will be having runner and buckets and casing and the braking net. So these are the components or parts of a Pelton wheel. So let us see what is nozzle and flow that is a spear. See, spear is basically, it is a conical needle. Okay, so that is operated by hand wheel or automatically. It is automatically, so you can see here. See, this is a nozzle. This particular is a nozzle, and you have a penstock. At the nozzle, you have a spear. This is a V spear along with the wheel. So this is a jet of water. So this wheel is this spear is a hand wheel operated by a hand wheel or automatically in an axial direction depending upon the size of the unit. So based on the size of unit, so this is operated, and this is used to control the water striking the vane. See, basically if you move the spear forward, it will close the nozzle, then it will decrease the volume of water. Then if you move the spear backward, then what happens, it will increase, it will open up and it will increase the volume of water coming out through the nozzle. So basically it is used to increase and decrease to regulate the flow of water. And the next component is runner and the buckets. See, runner is a consists of a circular disc, okay, and you can see here, so on that circular disc a number of evenly spaced buckets are fixed. You can see these are the buckets. So and this part is a runner. So it is a circular disc where on this circular disc a number of evenly spaced, means the distance between one bucket to another bucket is constant. So evenly spaced buckets are fixed, and here the shape of the bucket is a double hemispherical cup or a bowl shape. So you can see it looks like a bowl. Okay, and here, so this bucket, the entire cup or the bucket is divided by a dividing wall that is called a splitter. You can see this is a dividing wall which is called a splitter. So what happens, once the water comes and strikes, the water will directly come and strike on this splitter. Once it comes and strike the splitter, the water will be divided into two equal parts and it will come out through the outer edge of the bucket like this. So it will come and hit, the splitter will divide the water into two equal parts and the water will comes out through the outer edge of the bucket. So that is a runner and a bucket arrangement. So as I told, you will be having a splitter. So you can see here also this is a splitter. So where the water will come and hit this splitter and it will divide the water into two symmetrical parts. And also the most important is the bucket. Here the bucket is designed in such a way that once water comes and strike the splitter, so the jet will be deflected by an angle 160 degree or 170 degree. So it is designed in such a way that the jet will deflect by an angle 160 or 170 degree. And here, so the buckets are made up of cast iron, stainless steel, so based on the inlet head. So the material which is used is cast iron or stainless steel. The next component of a Pelton wheel turbine is a casing. So here you can see a Pelton turbine. So how it actually will be the arrangement of Pelton wheel turbine. So you'll be having nozzle here, penstock along with the nozzle and spear. Jet of water comes and strike like this, and you have a runner here, and the runner will rotate and vanes, and around that you have a casing here. So basically, what is the function of this casing? See, to avoid the splashing of water. Okay, so because once the jet strikes, the water will splash like this. To avoid that splashing of water and discharge that water into the tail race channel, the casing is provided, and also it acts as a safeguard against the accident. So due to the high velocity of water, sometimes it may happen that the vane may break down. So to avoid that accident, the casing is provided. And here the material which is used to made up of this casing is a cast iron or a fabricated steel plates are used to make this casing. And here the casing does not perform any hydraulic function. It just acts as a safe, it is just provided for this safety purpose. It won't perform any hydraulic functions. And the next component of Pelton wheel is a braking jet. See what happens, when you close a nozzle, means through the spear, if you close the nozzle, for example, if you see this figure, you just assume you have closed this nozzle completely using the spear. Then obviously what happens, the entry of water will stop. So even though the water has been stopped, then the runner will be still rotating due to the inertia. So to stop that runner with a less time, that is to stop the runner fastly, what we are going to do, so we are going to provide a braking jet nozzle. Okay, so as I told, okay, once you close the nozzle completely by moving the spear in the forward direction, the amount of water striking the runner will reduce us to zero. But due to the inertia, what happens? The runner will be still rotating for a very long time. So to stop that runner in a very short time, a small nozzle will be provided which directs the jet of water on the back of the vanes. Like for example, if you consider this, so here on the back of the vanes, a jet of water has been provided by the nozzle to stop the rotation of the runner. That particular jet of water is called the braking jet. So braking jet means that is a jet of water, so which is directed by the small nozzle to stop the runner in a very short interval of time. So that particular jet is called braking jet because you're putting a brake for the movement of vane. So that is called the braking jet. So these are the components of a Pelton wheel. Thank you all. Let us continue in the next class.